Hi students, this is lesson 728 part 3. Right now I'm on page 12. And what we're going to do is solve inequalities with multiplication and division. And there shouldn't be any problem except there's one little catch. There's some times where you need to change the inequality sign, and I'll go over that right now by showing you this little example. So let's say we start with the inequality 4 that's greater than 1, and we start doing some things to that. So I'm going to multiply both sides by 3. When I do that, I get 12 and 3, and 12 is definitely greater than 3. So we still have a greater than sign. 4 times 2 is 8, 1 times 2 is 2, 8 is greater than 2. 4 times 1 is 4, 1 times 1 is 1, 4 is greater than 1. 4 times negative 1 is negative 4, 1 times negative 1 is negative 1. Negative 4 is actually less than negative 1. Notice how the sign switched when we multiplied by negative. And that continues to be the same. 4 times negative 2 is negative 8, 1 times negative 2 is negative 2. Negative 8 is less than negative 2, and negative 12 is less than negative 3. So the story here is that if you multiply both sides by a negative, you need to reverse the sign. That's also true if you divide both sides by negative. If you multiply or divide both sides by a positive, you don't have to switch the sign. So here's that concept written out symbolically. Go ahead and fill in these answers, and to the best of your ability, you can check back with your further solutions. Pause now. All right, so here's your answers to those, and you can see that when you are multiplying or dividing by negative, you need to reverse the sign. So think about what you're doing as you're solving it. In this first problem, I'm dividing by 2. So to solve that, I'm going to want to multiply both sides by 2. When you multiply by a positive number, it doesn't change the sign. So my sign is going to be the same, and I get x is less than negative 6. So I'm going to put, since it's less than, I need an open circle, and less than would be to the left of negative 6. Then I'm just going to check one of those solutions, like I'll check negative 8 here, see if that one's right. So I'm going to put that in the original inequality and use negative 8 for x. So negative 8 divided by 2 should be less than negative 3 if it's a good solution. Negative 8 divided by 2 is negative 4, and negative 4 is less than negative 3 is true. So I got that part of the solution right. All right. Go ahead, you try this one, and I'll check back with you. You should pause now. Okay, there's your answers. We're going to do this little activity in class next time we meet to help you understand why you need to switch the sign a little bit better. So I'm going to move on to problem number 2 here. In this problem, we're multiplying negative 2/3 times w, and that has to be greater than or equal to 2. Now to solve this, since it's times there, I'm going to divide 2 by negative 2/3. But the way we divide fractions is we multiply by the reciprocal, which is negative 3/2. When I multiply a number by its reciprocal, I get 1w. Now I just multiply both sides by negative numbers, so in this case I can switch the sign around. And 2 times negative 3 is negative 6 divided by 2 is negative 3. So I get all numbers that are less than or equal to negative 3 should be the solution. So I'm going to put a solid dot there and go this way. To check that, I'm going to check my boundary point of negative 3, make sure that's right over here. So I'm checking negative 3. Then I'm going to choose one other number down here to see if that's also right. And since I'm dividing by or multiplying by 2/3, I'm going to check a number that's a multiple of 3. So I'll check negative 6. So I'm going to do negative 2/3 times negative 3 and see if that's greater than or equal to 2. And negative 2/3 times negative 3 is positive 2. And that equals 2. So that's the right boundary point. Then now I'm going to check negative 6. So I'm going to do negative 2/3 times negative 6 and see if that's greater than or equal to 2. And negative 2 times negative 6 is positive 12 divided by 3. 4, and 4 is greater than 2. So that checks. All right, you go ahead and try it. You should pause now and try and do this on your own. You can check back with the answers. All right, so there's the answers. Okay, moving on. Let's try another problem here. Now, division property of equality, again, works the same way as multiplication. If you're dividing by a positive number, you don't switch the sign. If you're divided by a negative number, you should switch the sign. So here's a problem, and we're going to write an inequality to represent this. Cheerleading squad earns $5.50 per car wash. How many cars does the squad need to wash to earn at least $77? We saw on some previous problems that at least can be represented by inequality greater than or equal to. And let's let X be the number of cars they wash. So the number of cars washed is X. So they're going to get $5.50 per car. So if we take $5.50 times X, and they have a goal to earn at least $77. So 550X times the number of cars washed should be greater than or equal to 77. And to solve that, we're going to divide both sides by 550. When you divide by a positive number, the sign stays the same, nothing to worry about there. So we're going to still have greater than or equal. And so X should be 77 divided by 550 is 14. Interpreting that, greater than or equal means, in this case, at least. So they must wash at least 14 cars. All right. You try that. Go ahead and pause now, and we're going to try the next problem, and then you can check back solutions. Okay, here's your solutions. All right, let's try a division, a problem that we need to divide with a negative in it. So we have 5a is greater than or equal to 20. To solve that, since we're multiplying by a -5, we're going to divide by -5. Now remember, when you divide by a negative, you need to switch the sign around. So we're going to do that right away. -5 divided by -5 is 1a, and 20 divided by -5 is -4. And so any number less than or equal to -4 is the solution. So I'm going to put a closed circle there and make my arrow go this way. Now I'm just going to check one of these solutions in here. Since I'll just pick -6, see if that one works. It should, since it's part of my solutions. So if I take -5 times -6, it should be greater than or equal to 20, the original inequality. And so we get 30 is greater than or equal to 20. That checks. And I'm pretty sure that's the right answer then. All right, go ahead, you try that. Pause now and try this problem. All right, that's it for this lesson. Go ahead and finish that up, and we'll see you next time we meet in class.